Here we have a problem. In a particular crash test, an automobile of mass 1,576 kilogram collides with a wall and bounces back off the wall. The X components of the initial and final speeds of the automobile are 21 meters per second and 3.4 meters per second, respectively. If the collision lasts for 0.15 seconds, find the magnitude of the impulse due to the collision. And then the second part is calculate the magnitude of the average force exerted on the automobile during the collision. So first of all, we need to write down our givens. So we're going to write down a G, and then we're going to reread the problem. In a particular crash test, an automobile of mass 1,576 kilograms, mass equals 1,576 kilograms, collides with a wall and bounces back off the wall. This is important. Bounces back off the wall. The X components of the initial and final speeds of the automobile are 21 meters per second and 3.4 meters per second, respectively. This respectively means with respect to initial and final. We have the words initial and final, and then we have the numbers 21 and 3.4. That means that 21 goes with initial and 3.4 goes with final because they're in the same order. So we're going to write this in terms of velocity. We're going to give it a direction. Speed is a scalar. It doesn't have direction, but velocity does. So we're going to say V initial and V final, and we're going to give them directions. Now, if we say that the initial speed was in this direction, and that this thing hits a wall, and once it hits the wall, it bounces back, then this is V final. So if this is V initial, it's traveling to the right, and so we're going to call that a positive velocity, and that means if this is positive, then this direction is negative. So we're going to go back and we're going to say, okay, the initial speed of the automobile is 21 meters per second, and it's positive. And the 3.4 is the final speed, and it's negative. Direction is important when we're talking about vectors. Okay, if the collision lasts for 0.15 seconds, time is not mentioned, but it gives the word lasts. That implies how long, and it gives a unit of seconds, which is the unit for time. So we're going to say time is equal to 0.15 seconds. Then it says find the magnitude of the impulse due to the collision. So our unknown is going to be impulse, force multiplied by time. Okay, so the equation, well, we know that impulse equals force multiplied by time, and it also equals the change in the momentum, which is going to be mass times final velocity minus mass times the initial velocity. Okay, so we cannot find the impulse using this formula because we don't know the force. So we're going to use this second equation for impulse, which is change in momentum. So we're going to plug this in. F times T is going to be equal to 1,576 kilograms times negative 3.4 meters per second minus 1,576 kilograms times 21 meters per second. So then we write our solution S, and we take the difference between these two. So 1,576 times negative 3.4 is equal to negative 5,358.4 kilogram times meters per second. And we're going to subtract from that negative value this value, and this is 1,576 times 21, and that's going to be equal 33,096 kilogram meters per second. So if we subtract that, we end up with negative 38,454.4 kilogram meters per second. So this is our answer. Of course, the units are written down on the side because I ran out of room. I write big. And so that is our impulse. Sometimes you'll see that F times T is written as an I for impulse. Some books you see that, some you don't. So I'm just writing it this way so that we can see there's two formulas or two relationships that are equal to each other. Okay, so this is our answer for the first part, but let me point out to you that this says magnitude. Magnitude is the strength of the vector, not the direction. In this case, 38,454 is the strength, and the minus sign is the direction. And therefore, the answer for the homework is 38,454.4 kilogram meters per second. Notice we're not using significant digits. So if you know significant digits, you can use them for the homework. That's not necessary. Okay, so then it says calculate the magnitude of the average force exerted on the automobile during the collision. Well, we know that this is the impulse and it's equal to force multiplied by time. So we're given that F times T is equal to negative 38,454.4 kilograms times meters per second. And we're also given that the time is equal to 0.15 seconds. That was from the previous problem, and we have it right here. So these are our givens. Our unknown, we're looking for the force. The equation, well, force multiplied by time is equal to the change in the momentum, which is mvf minus mvi. And we've already found this. It's right here. And so we're going to substitute our other value, which is time, and we get force multiplied by 0.15 seconds equals minus 38,454.4 kilograms times meters per second. Divide both sides by 0.15 seconds, and we get our answer, which is force is equal to negative, here we go, sorry I'm not on the page there, force is equal to negative 256,363. I rounded that newtons. Okay, now